Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is Advitiya coin. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. During Advitiya, the coding club launched a brand new virtual stock coin called Advitiya coin ADC to give participants a taste of real world trading strategies. The price of ADC changes throughout the day and is recorded as an array P of size n, where each element represents the price of the stock at that time in that index I. Now, a participant can perform multiple trades during the day following the rule. A valid trade is one of the following. You choose an index I that is less than J. Then you buy the stock at I and sell it at J. Or you can do the reverse. You can sell the stock at I and buy it at J. Now, if a trade is made by choosing indices I and J, it means that no other buy or sell operation should take place between these indices I and J, both included. Now, if a trade incurs, every trade incurs a fixed transaction cost of K. Therefore, the profit of a trade is defined as the sell price minus buy price minus the fixed transaction cost, that is K. A trade is considered winning if its profit is strictly positive. Now we are given this array P of length n, denoting the price of stock at various time indices as well as the transaction cost of K. We need to compute the maximum number of winning trades that can be performed following the rule. Remember, we don't need to maximize the profit, just the number of winning trades. As for the input format, we have t test cases, and for each test case we'll have two lines. The first line will contain two integers n and k, that will be the length of the array and the transaction cost. And the second line will have n spaced integers p1, p2 till pn. As for the output, in a single line we just have to output the maximum number of winning trades that can be made. As for the constraints, number of test cases will go from 1 to 10 raised to 3, sorry, 10 raised to 5. Value f value of n will go from 1 to 2 into 10 raised to 5. Value of elements and k will go from 1 to 10 raised to 9. Let's see some sample input. So for the very first sample input, we have n is equal to 5. That means we'll have 5 elements. And the value of k is 1. So let's say we start. This is the p 1, 3, 2, 5 and 4. We can pick and choose 1 and 3. If we do so, the difference between them, that is the selling price, let's say it be the 3. 3 minus 1, this gives us 2, and if we remove the transaction cost, we have 1 remaining. So this is a winning trade. Next up, we can choose 2 and 5. You can also choose 2 and 4, but still the difference will be more than the cost of the transaction. Therefore, we have 2 total winning trade. Whereas if you see the last sample input, where we have 0 transaction cost, but all the values are same. So even though you buy and sell at the same price, the profit is not positive. Therefore, the number of winning trades is 0. Let's see how we can approach the solution. Now the first thing to know is that we just need to find two numbers where the difference sorry, is greater than the transaction cost. Now in that case, let's see if we have A and B. If the difference between them is greater than the transaction cost, right, then we can consider this as a winning trade. But the thing is, once we have done this trade, we cannot make any trade with the elements that are in between. And our goal is to maximize these trades. So what we can do is, as we are going through our array P, when we have an element, we will simply check what is the minimum and maximum because we want to maximize the difference between them so that we can have a winning trade. Once we choose a number, and the moment we find another number where the difference is greater than the cost, we can consider it as a winning trade. But once we do this, we need to abandon all the elements that we have seen before this and start anew. So for this, what we'll do is we'll go over the elements, make our winning trades, and the moment they are done, we'll reset our elements, that is the buying and selling, and keep on doing so until we reach the end of our array. So something like what we have done in the first sample input. We have 1. The moment we see 3, we know that this is a winning trade that we can make. So the trade is done and we forget all these elements. Next up, we again now start with 2, that is we start afresh. We have 2. Next element that we go for is 5. Once we have 5 here, we know that the difference gives us enough leeway that we can make a winning trade. So we do so and we again move to the next number. Since after this we do not have any option, we only have single element, so we could not make any more winning trade. But this is a strategy that we can follow and get a solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve, take the input of n and k, and then we take the input of our array. We initialize our number of winning trades, that is result as 0. We initialize maximum as a very big negative number and minimum as a huge positive number. Then as we go through our array, we initialize the values of minimum and maximum. We keep on updating them until the difference between maximum and minimum is greater than the transaction cost. If that is the case, we have got our winning trade. We increment the count by 1 and reset the minimum and maximum. We keep on doing this until we exhaust all the elements in our array. At the end, we'll have the count of winning trades, and this is the maximum that we can get. And as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n, k, and our input array. We initialize our result as 0 and initialize the minimum and maximum variable. We go over all the elements in our array, updating the minimum and maximum. Once the difference reaches more than the transaction cost, we record it as a winning trade and reset the minimum and maximum variable. We do this until we have exhausted all the elements, and finally we have the count of winning trades that we could make. And as you can see, I have AC in Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.